Hey guys, welcome. So in this video, we're going to talk about what we mean by fields in mathematics, in particular, in abstract algebra. So fields are something that you study after you study groups and then you study rings, because first and foremost, fields are rings. So it comes as no surprise that a field is a set together with two binary operations, plus and star. Just like rings, a field comes with two binary operations, and of course, a field must fulfill all the requirements of a ring. So it is first, that is the field, whatever field we're considering, must first be a ring where star is associative, so where multiplication is associative. But additionally, right, so far one is just a requirement for a ring. But yeah, additionally, for a field, we require that star be commutative. So multiplication is commutative. And we have a multiplicative identity, and we have multiplicative inverses. If all these conditions are met, then you've got yourself a field. Yeah? Okay, so in very, very basic terms, in groups, we can add and subtract. And really, when we say subtract, we're just saying adding the additive inverse, right? But yeah, in groups, we can add. And in rings, we can add and therefore subtract, but we can also multiply in rings, right? And what makes fields different is that we can also divide. So we can do all the things that we did in rings, but we could also divide in fields. Yeah? So that's a basic summary. And of course, by divide, we mean multiplying by the multiplicative inverse. Remember, in this final requirement, we require that fields have multiplicative inverses. Yeah? Okay, cool. And so with this, then, let's look at some examples of fields. So some of them are all too familiar. For example, the real numbers form a field with the usual addition and multiplication, and so do the complex numbers. The complex numbers also form a field with complex number addition and complex number multiplication. Yeah? But what's really, really cool that you're going to find very interesting is this cute little field that I had to do as the last problem on my very first homework on my very first year in college as a math major, which is, well, take the set that simply has 0 and 1 together with addition and multiplication, usual addition and usual multiplication, where the following two tables define the addition and the multiplication. Well, first, we can see that with this Cayley table, we have that addition forms an abelian group. And this is the very same table that we used when we introduced groups. And so we checked then that it forms a group, but you could also check that it's commutative with respect to addition, this here, and therefore it's an abelian group with respect to addition. This field that we're about to show is a field, right? Okay. But yeah, in addition to addition, we also have the table for multiplication here. And so if we take both tables together, then we can see that we also have star, which in this case is multiplication, is distributive, both right distributive and left distributive. And you can check more carefully using the elements here, 0 and 1, and the addition and multiplication tables defined respectively. Yeah? Okay, but you can also check that star, which is multiplication here in this table, is associative, and therefore we have, with these two tables and this set, and so addition and multiplication defined by these two tables in this set, we have a ring. Yeah? So to see that we also have a field, we need to check that multiplication is commutative, and you can do that carefully if you'd like, but it is. This table shows that the multiplication is commutative, the second table. We also have a multiplicative identity, the number 1, right? And yeah, we additionally have the last requirement for fields, which is multiplicative inverses, right? Now, when we're talking about fields and multiplicative inverses, we're talking about multiplicative inverses for the non-zero elements. Yeah? Okay, so here, 1 is its own multiplicative inverse. Yeah? Okay, cool. And so we see that we have all the requirements complete for a field, and therefore this final example shows that we have a third example of a field in this video, but this won't be the last. I'll have at least one additional video expanding more on the discussion in this video, and so a second video on fields if I wasn't clear. All right, I hope you enjoyed this and keep watching. Take care.